In today's lesson, we are going to be looking at graphing other trig functions. So tangent, and then the reciprocal functions, cotangent, cosecant, and secant. And in this lesson, we're just going to kind of touch on the basics of these graphs and not do a bunch of specific examples. So to create these graphs, I want you to think about the values of these functions on the unit circle. So starting out, tangent of x is equal to your sine values divided by your cosine values. So if we think about that unit circle, and I'm just going to pick a point, let's say pi over 2. So tangent of pi over 2 would be equal to sine of pi over 2 divided by cosine of pi over 2. Well, let's see, that's the point 0, 1. So this is 1 divided by 0. Oh, so tangent is undefined at pi over 2. If it's undefined, that means vertical asymptote. So at pi over 2, I will have a vertical asymptote. And then that is also going to happen at 3 pi over 2. And at 5 pi over 2. So the tangent function has a vertical asymptote every pi. So starting from pi over 2, and then the distance from the asymptotes is the distance of pi. Let's think of another value. So what if we just did tangent of pi? So that's the point -1, 0. Sine is 0, cosine -1, so that equals 0. So at pi, I have 0, and that's going to be at every pi, 2 pi, 3 pi. And what the tangent function does, it has these asymptotes, then it goes through pi and then goes up. And then that repeats over and over and over again. So the domain for tan, it's all real numbers except x does not equal pi over 2 plus multiples of pi. And then the range of the tangent function is all real numbers. And now a couple other things to just note. We're not going to do specific examples in this video, but just like sine and cosine, you can translate, reflect, you can have phase shifts of the tangent function. And then periods of the tangent function. So to find the period, it is pi divided by the absolute value of b. So not 2 pi, but pi, because it repeats every pi. And then you can find those asymptotes by doing these little equations. So if you have a phase shift, that is going to shift those asymptotes. So if you take that bx plus c and you set an equation, set it equal to pi over 2 and negative pi over 2, solve for x, then you can find the new asymptotes with that phase shift. Okay, once you understand the tangent function, the cotangent is pretty easy. So cotangent of x is cosine of x over sine of x. So if we think cotangent of pi over 2, it kind of flips. So this is 0 over 1, which is 0. So pi over 2, that's where it crosses. And then if we look at cotangent of pi, that's the 1 over 0, which is undefined. So at pi, and then actually it's also 0 here. So we have all these asymptotes there. And then it's going to go in the opposite direction. So instead of an increasing function in between the asymptotes, it is a decreasing function. So the domain is, it's all real numbers except x does not equal multiples of pi. And then the range, also all real numbers. And just like tangent, we can have transformations of cotangent. So a times cotangent bx plus c plus d. And just like tangent, the period is pi divided by the absolute value of b. And if you have a phase shift, to find the asymptotes, very similar, you take that bx plus c, but instead we're setting it equal to 0 and to pi to solve for the asymptotes. All right, next function, cosecant. So if you remember, cosecant is 1 over sine. Just like the last two, if we have x in that denominator, there's going to be asymptotes. So it's asymptotes anytime that sine of x equals 0. So where is sine 0? It's at 0, at pi, at 2 pi, at 3 pi. So at multiples of pi, we have asymptotes. And I'm going to change how this graph is labeled. I'm going to go count by pi over 2's. So pi, 2 pi, 3 pi, 4 pi. And asymptotes at every pi. And then let's think about pi over 2. At pi over 2, sine of pi over 2 is 1. And sine of 3 pi over 2, it's negative 1. So the graph of cosecant does this. They're almost like these little parabolas. This one goes up, then this one goes down. Then this one goes up. And this one goes down. So they're not really parabolas because they have asymptotes on both sides, but they kind of have that shape. And that just repeats. So the domain, all real numbers, except x does not equal multiples of pi. And the range, if you look, this is going to go from negative infinity to negative 1 and 1 to positive infinity. So there are no y values in between negative 1 and 1. And kind of one way to help you memorize this, remember cosecant and sine, they're buddies. So draw sine on here real quick. So the max of sine, minimum of sine, kind of hit those same points. And then sine would cross at those asymptotes. So you can kind of see the difference between sine and cosecant. And once again, you can have transformations of cosecant. To find the period, it would be 2 pi divided by b. And then the asymptotes. If you have that phase shift to find the new asymptotes, it would be that bx plus c, and you'd set it equal to negative pi, solve for x, set it equal to pi and solve for x. Okay, last function, secant. So secant of x is equal to 1 over cosine. So once again, in the denominator, so we're going to have asymptotes. And they will happen anytime cosine equals 0. So that would be at pi over 2 and 3 pi over 2. So asymptotes will go there. And then at 0 and pi and 2 pi, So at 0 and 2 pi, that is when cosine is 1. Cosine of 0 is 1. Cosine of pi is -1. So let's see, at pi it's -1, but at 0 it was 1. At 2 pi it's at 1. 3 pi, -1. So it looks just like the cosecant 1, except the asymptotes are in a different spot. And another way to help you remember the difference, so if you think of cosine, cosine starts up, and then it always, so hits the 0 at pi over 2, hits this one. So there's the cosine function. So sometimes, because we know the cosine and cosine so well, we can use those to help us distinguish between cosecant and secant. So domain and range. Domain of secant is all real numbers except x cannot equal pi over 2 plus multiples of pi, and the range is from -infinity to -1 and 1 to infinity. And following the same theme, we can have transformations of this, same as all the other trig functions. Whoops, bx plus c. So in this one, the period is 2 pi divided by b, and then the asymptotes. If there's a phase shift, to find the new asymptotes, it's that bx plus c set it equal to -pi over 2 and 3 pi over 2. So there's your full video on these 4 other trig functions, just trying to get all the basics, and then together in class we will practice some of those transformations of these functions.